yi plus h into si. Thus, yi plus 1 can be obtained by the generic equation yi plus 1 is equal to yi plus h into s. This is the equation of Runge-Kutta second order methods. Let us quickly take an example. Given the following ordinary differential equation with the initial condition y of 1 equal to 5, find the solution in the interval 1 to 1.5 using step size h equal to 0.1, and our ODE dy by dx is given as x into y. yi plus 1 is equal to yi plus h into s, and s is the average of the two slopes. F of xy is equal to x into y, which is given to us. H is given to us as 0.1. x1 is known initial value 1, and y1 is known as the initial value 5, which is given to us. Substituting these values to compute S1, we have S1 is equal to f of x1 y1, which is f of 1 and 5. What is f of xy? X into y. So that is 1 into 5, and the value is 5. So the value of S1 is 5. S2 is equal to f of xi plus h, y1 plus h into s1. What is x1? 1. What is h? 0.1. And hence xi plus h, that is the next point, is 1.1. And y1 plus h into s1 is 5.5. F of xy is x into y. So we simply multiply 1.1, 5.5, and the value we get is 6.05, which is now the value of S2. We need to find out S, which is the average of these two slopes. That is 5 plus 6.05 divided by 2, which is now 5.525. Substituting these values in y2 equal to y1 plus h into s, that is y1 is 5, h is 0.1, and s is 5.525, we get the value y2 is equal to 5.5525. Subsequently, calculating these values for the other points 1.2, 1.3, 1.4, and 1.5, we can get the values of yi plus 1. So now I understand that we have had a good understanding about the one-step methods or single-step methods, which are Taylor series, Euler's method, Runge-Kutta second order method, and in Runge-Kutta fourth order method, we shall be considering four slopes. Like in Runge-Kutta second order, we consider two slopes between 2 points. Now we shall compute four slopes, find their weighted averages, and substitute in the general formula yi plus 1 is equal to yi plus h into s. This will give us the subsequent values of the yi's. Certain practical applications of ordinary differential equations. These ordinary differential equations are used in law of cooling, law of motion, the radioactive decay, force of a moving board, Kirchhoff's law for an electric circuit, and even heat flow in a rectangular plate. Now these are all scientific applications which make use of ordinary differential equations. Since the scope of the syllabus is limited to initial value problems and one-step or single-step methods, I think we have now a good understanding of how to find the solution of ordinary differential equations. Thank you.
SANDHAN, All Gujarat Integrated Classroom.
સેટેલાઇટના માધ્યમથી જોડતી કડી એટલે સંધાન.